A single plant grows at the edge of every marsh, every drainage ditch, every forgotten pond. Ethnobotanical surveys published in Economic Botany documented over 40 distinct uses of Typha latifolia across indigenous North American cultures alone. In 1972, researcher Daniel Moorman cataloged cattail as one of the most comprehensively utilized wild plants on the continent. Roots, shoots, pollen, and seed fluff harvested across every season. A 2010 study in the Journal of Ethnopharmacology confirmed that Typha rhizome flour contains starch concentrations rivaling cultivated wheat, produced with zero agricultural input. No irrigation, no fertilizer, no harvest machinery. The plant colonizes disturbed wetlands and rebuilds them while feeding whoever is willing to look down. Industrial agriculture never came for the cattail. It could not be patented. It could not be standardized. It could not be shipped in a plastic sleeve. So it was quietly erased from collective memory, not by failure, but by inconvenience. Every civilization that lived near water knew this plant intimately. Every civilization that moved to the city forgot it completely. The cattail did not disappear from the landscape. It disappeared from the mind. And somewhere inside its quiet, unremarkable silhouette is one botanical secret that will reframe everything you thought you knew about wild abundance. Long before grain silos defined civilization, cattail rhizomes fed people through the harshest winters. Archaeological evidence from Great Basin sites places Typha root processing at least 10,000 years into the past. Paiute, Chippewa, and Ojibwe peoples harvested rhizomes in late autumn, pounding them into a starch-rich flour that stored without refrigeration. The roots contain caloric density comparable to wheat, a fact confirmed by USDA nutritional analyses of wild Typha rhizome. This was not survival food. This was the foundation of seasonal nutrition. Medieval European villagers along river deltas also relied on Typha shoots in early spring. Botanist John Gerard documented its use in his 1597 Herbal, one of the earliest English botanical encyclopedias. The rhizomes were not merely edible. They were abundant beyond reason. A single hectare of mature Typha can yield between 3 and 8 tons of harvestable rhizome starch annually. That figure exceeds the yield of many traditionally cultivated cereal crops on equivalent land. The system did not need to be planted. It only needed to be remembered. History reveals that the most productive food systems were never designed by humans. They were inherited from ecosystems that had been optimizing for millennia. No other temperate wetland plant offers edible material across as many distinct growth stages as Typha latifolia. In early spring, young green shoots emerge from rhizomes, tender, pale, and dense with nutrients before the plant commits to height. As spring advances, the inner core of the developing stalk becomes crisp and sweet, historically described by foragers as resembling cucumber crossed with corn heart. By late spring, the green male flower spike appears before it releases pollen, and this moment is brief, documented, and extraordinary. Typha pollen is produced in quantities that stunned early botanists. A single mature stand can release kilograms of golden pollen within days. Indigenous peoples across North America collected this pollen as a flour supplement. Its protein content documented at over 6 grams per 100 grams of dry weight. Then summer arrives, and the familiar brown seed head forms. The seed fluff, technically a coma of fine fibers, was used historically as insulation, wound dressing material, and fire-starting tinder across cultures on 3 continents. Autumn strips the plant back to its roots. But below the waterline, the rhizome network is preparing a new surge of stored starch. Winter does not kill cattail, it only drives it deeper. The plant that appears dead above the surface is quietly banking energy below the frost line. Nature designed this not as a seasonal crop, but as a permanent infrastructure. Modern agriculture built its empire on monoculture, one crop, one input, one harvest, one profit margin. Cattail offers the opposite, a multi-harvest, multi-use, self-regenerating system that requires no human management. That is precisely why it was never industrialized. You cannot spray a wetland with herbicide and replant it with cattail on a quarterly schedule. You cannot engineer a combine harvester that navigates standing water at dawn to collect pollen for 48 hours before it disperses. The industrial machine demands obedience. Typha offers only independence. In the 20th century, as agricultural corporations consolidated food production, wild plant knowledge collapsed within 2 generations. University extension programs trained farmers to grow soybeans and corn. Nobody trained anyone to read the edge of a marsh. Ethnobotanist Gary Paul Nabhan documented this collapse extensively in his research on the erosion of traditional food knowledge in North America. The knowledge did not vanish because it was proven wrong. It vanished because it was never written into a curriculum that generated revenue. The swamp had no lobby. The cattail had no marketing budget. And so an entire continent walked past its most productive wild pantry without recognition. The most surprising chapter in Cattail's story is not the root or the shoot. It is the pollen. For a window of roughly 2 weeks each year, Typha latifolia produces a surge of golden pollen, so dense it stains the water around the plant. Historical records from multiple indigenous nations document pollen collection as a ceremonial and nutritional event, not a casual foraging act. The pollen was mixed with other starch sources to enrich breads and flatbreads, adding color, flavor, and nutritional density. Modern laboratory analysis confirms Typha pollen contains flavonoids, including isorhamnitin and kaempferol, compounds studied extensively for their biological activity in peer-reviewed literature. The lab results surprised researchers. This was not agricultural waste. This was a precision ingredient that appeared once a year and demanded immediate harvest. The urgency of the pollen window created a seasonal ritual across cultures separated by thousands of miles. From the Klamath people of Oregon to wetland communities in Eastern Europe, the golden dusting of cattail marshes in late spring triggered coordinated harvest. Industrial food systems have no category for an ingredient that appears for 2 weeks, cannot be stored at scale, and refuses to grow in rows. So the pollen was forgotten, along with the knowledge of how to find it. The marsh still produces it every year. The knowledge of its value simply stopped being passed down. Cattail is not merely a food source, it is an ecological engineer. Typha stands filter agricultural runoff, capturing nitrogen and phosphorus before they reach open water, a function studied extensively in constructed wetland systems. A 2004 paper in ecological engineering demonstrated that Typha-dominated wetlands reduced nitrate concentrations in agricultural drainage by up to 95% under optimal conditions. The plant builds soil, it traps sediment, accumulates organic matter, and creates the conditions for biodiversity to return. Where Typha grows, water quality improves. Where it is removed, degradation accelerates. Yet land management authorities in multiple countries have historically treated Typha as a nuisance weed, a plant to be dredged, burned, or chemically suppressed. The logic was drainage. Productive land needed to be dry. Wetlands were obstacles to agriculture, not partners to it. This is one of the most consequential ecological mistakes of the 20th century. Billions of dollars are now spent annually attempting to recreate the water filtration functions that Typha performed for free. Constructed wetland technology, essentially the deliberate planting of cattail in engineered channels, is now a recognized tool in wastewater management across Europe and North America. Science spent a century destroying what it now spends billions rebuilding. The plant never moved. The understanding finally caught up. Nature does not invoice for its services. but the cost of ignoring them is always collected eventually. The revival of interest in Typha latifolia is not a trend, it is a reckoning. Permaculture designers, wetland restoration ecologists, and ethnobotanists are converging on the same conclusion. The most productive landscapes are the ones we abandoned. Cattail requires no soil preparation, no purchased seed, no synthetic input. It establishes itself on degraded land that conventional agriculture has already surrendered. In Central Asia, Typha species have been used historically in the construction of woven mats, thatched roofs, and basketry. The seed fluff stuffed into pillows and sleeping rolls across steppe cultures. In North American wetland restoration projects, Typha is now deliberately reintroduced to stabilize eroding shorelines and rebuild aquatic habitat. The same plant that was dredged out of canals for a century is now being replanted at public expense. This is not contradiction. This is the slow correction of a systematic error. Small-scale growers and homesteaders with access to even a modest water feature can establish a Typha stand within a single season. The plant spreads aggressively via rhizome. Once established, it asks for nothing. It produces harvestable material every year without replanting, without watering, without intervention. The margin of the pond, the space most gardeners fence off and ignore, is the most productive zone on the property. Ancestors did not fence off the waterline, they cultivated it with attention and respect. The cattail stood at the boundary between land and water, and it fed every civilization wise enough to notice. Typha latifolia did not go extinct, it did not retreat, it did not adapt to survive human indifference. It simply continued doing what it had always done, growing at the edge of every neglected waterway on the planet. The cattail outlasted empires. It outlasted the civilizations that harvested it and the agricultural systems that replaced them. It is growing right now at the edge of drainage ditches alongside highways, in the margins of retention ponds behind shopping centers, in the forgotten corners of municipal parks. The knowledge required to engage with it is not complex, it is only absent. Every generation that loses botanical literacy loses a layer of independence from the industrial food system. Every generation that reclaims even a fraction of that literacy reclaims a degree of sovereignty over its own sustenance. The cattail does not ask to be cultivated, it asks only to be recognized. In a world increasingly dependent on supply chains, refrigeration, and plastic packaging, there is something quietly radical about a plant that grows in mud and offers abundance without conditions. The swamp was never a wasteland, it was always a pantry. The label changed, the plant did not. Somewhere at the edge of almost every body of water within reach, Typha latifolia is standing in shallow water, green and indifferent, waiting for the moment when someone decides to pay attention again. The supermarket of the swamp has never closed. It has only been ignored.